Now you need to keep in mind that vesicles can form and bud off from the cytoplasmic face of the plasma membrane, from the various endosomal compartments, from the Golgi apparatus and from the endoplasmic reticulum. And all these vesicles are trafficking to specific organelles or membranes in the cell. So how does the cell ensure that the right vesicle ends up at the right membrane? Well, the cell can use the trackways and motor as part of the process. That is, the track sends the vesicle in the right direction. But the cell can also use proteins to help with target recognition, and this process is called the SNARE hypothesis. In the SNARE hypothesis, vesicles have on them a vesicle SNARE or vSNARE, and the target membranes have a tSNARE, a target SNARE. And the different vesicles and target membranes have different V and T SNAREs that can recognise each other. And this therefore ensures that the correct vesicle docks and fuses with the correct membrane. Hence, we get specificity through the SNAREs. However, as I'm sure you can guess, things are never that simple. One of the problems with the SNARE hypothesis is that the V and T SNAREs are promiscuous. That is, they are not exclusive in their binding habits, plus the different SNARE proteins are not limited to specific membranes. In addition, the interaction of the SNAREs appears to happen over a distance that is further than they could span. So these issues are addressed by an additional layer of proteins in the process called the tether proteins. The tether proteins can operate over greater distances than the SNAREs, so that solves the distance problem. Plus, the tethers add another layer of specificity to the process. That is, you have to get a match in the tethers and the SNAREs for the vesicle to dock and fuse with the membrane. And it now appears that the role of the SNAREs is more to do with the fusion of the vesicle to the membrane than with recognition. Hence, we now have a mechanism by which the vesicle can recognise its target membrane through the use of tethers and SNAREs. And we also have a mechanism by which the vesicle can then fuse with the target membrane. And unsurprisingly, a lot of this process is driven by a GTP timer, but you don't need to know about the mechanism and how it works here.